Okay, in this video, we are going to start the process of calculating the one-way ANOVA by hand. And we're going to do this using the formulas, not the long way using those deviation scores, but using the actual formulas for the one-way ANOVA. So before we start this problem, just to remind everybody of where we are doing a study looking at the relationship between noise and memory. We have a group of 5 people that we assigned to a noise condition. We have a different group of 5 people that we assigned to a no noise condition. This is level A1, level A2. Here we've got our sums. Remember, we're referring to our sums by capital letters. Capital A1 is 5, capital A2 is 30. The N for each group is 5. And Y bar, which is the mean, Y bar for the groups are 1 and 6. Little a is the number of groups or the number of levels. In this case, we've got 2. N is the number of subjects per group. In this case, we've got 5. Capital T is the grand sum, which is the sum of all the scores, which is 35. And Y bar T is the grand mean, which is the mean of all the scores. So it's basically 35 divided by 10, but if you like a formula, it's T divided by A times N. So 35 divided by 2 times 5 is 3.5. All right, so the first step in the one-way ANOVA is to calculate something that we call basic ratios. And the basic ratios, honestly, this is the hardest step. So if you find this step to be easy, which hopefully many of you will, if you find this step to be easy, the rest of the problem is a cakewalk. So in the one-way ANOVA, there are 3 basic ratios. The first basic ratio is the basic ratio for y. And the way that we notate the basic ratios is we put the letter in brackets. So we have y in brackets. And the formula here is the sum of the y squareds. All right, so I'm trying to color code this for you guys. It's the sum of the y squareds. So our y's, these are our scores. So what we're going to do is we're going to square each of our y's, and then we're going to add them up. All right, so we're going to do all 10 of our y's. So we have 2 squared plus 0 squared plus 0 squared plus 1 squared plus 2 squared. And we're going to add these y's in there as well. So plus 5 squared plus 6 squared plus 8 squared plus 7 squared plus 4 squared. All right, so what we've done here is we've taken each one of our y's, these blue numbers, we've squared them, and we're going to add them up. And when you go through the steps of doing all of this, the answer that you get, I'm going to do this in black actually, the answer that you get is 199. And moving forward, when you do homework assignments for me, you definitely want to make sure that you either box your answers, circle your answers, or highlight them. Because as we move through this problem, there are many, many calculations, and that will make it easier for me to find them. Okay, so our next basic ratio is the basic ratio for A's. All right, and the formula for this, let me get my colored pen here. The formula for this is the sum of the capital A's squared divided by n. All right, so it's the sum of the capital A's squared divided by n. So we're going to take each one of these column sums, we're going to square them, add them up, and divide by n. All right, so our first column sum is 5. We're going to square that. Our next column sum is 30. We're going to square that. And then we're going to divide by n, which is 5. All right, so we've got 5 squared plus 30 squared divided by 5. And this equals 185. All right, we haven't done any magic here. All we've done is we've taken the column sums, squared them, added them up, divided by 5. And then our last basic ratio is the basic ratio for t. Let me get my colored pen here. The formula for this is capital T squared divided by little a times little n. All right, so our capital T, you can see over here is our grand sum. So we're going to take that, which is 35, square it, and divide by little a times little n. So 2 times 5. So 35 squared divided by 10 equals 122.5. All right, so again, basic ratio for y, we're going to take each of the y's, square them, and add them up. Basic ratio for a, we're going to take our two column sums, square them, add them up, divide by n. And basic ratio for t, we're going to take our t squared and divide by a times n. Now, a couple points, important points to remember. First of all, this formula for t, the basic ratio for t, is t squared divided by little a times little n. If you notice over here, the formula for y bar t is t divided by a times n. The only thing that makes these two formulas different from one another is that for the basic ratio for t, we're going to square that t. And this is a place that I see a lot of students mess up. Don't forget to square the t here. All right, I told you in the previous videos that as we move through the ANOVA, there's lots of checks that we can do to make sure that our numbers make sense. And I'm going to show you the first check here. When you do your basic ratios, the basic ratio for y should always be the biggest. And the basic ratio for t should always be the smallest. So let's look at this. Does this make sense? Is 199 the biggest? Yes, it is. Is 122.5 the smallest? Yes, it is. All right, another thing that you want to make sure as you're going through this, that these numbers are about, there's another thing you can look at to make sure that these numbers make sense. And it goes back to the point that I made earlier about this formula and not forgetting to square the t. These numbers should all be about the same range, right? So if we have 199, 185, and then we have 3.5 down here, this number is not in line with the other numbers, right? So we have numbers in the hundreds, and then if we have a tiny number down here, chances are we forgot to square that t. All right, so this is absolutely the hardest step of this problem. So if you found this part to be relatively easy, then the rest of the problem is going to be really just a walk in the park. So in the next video, I'm going to show you how to calculate the sums of squares and maybe a few other things.